Now there are total 6 steps involved in a hypothesis testing. These 6 steps are common irrespective of any type of the test. So in this category, our first test is for single mean. Now here the only difference from our previous single mean test is that the sample size is less than 30. Now since the sample size is less than 30, so here we will use t statistic instead of z. So the formula for t statistic is shown here on the screen. Now notice in the formula we have divided the standard deviation by the square root of sample size n for calculating the t statistic. So again we'll calculate the t statistic from this formula and then we'll proceed with the rest of the steps as shown here at the top of the screen. Now let's move on to the next step in this category, that is for the difference of mean. So we have already seen this when the sample size was greater than 30. Now the only difference is that in this case the sample size is less than 30. So when the sample size is less than 30, in this difference of mean test there are two possibilities. One is that our samples are independent and the second possibility is that the samples are dependent. Now dependent samples are also called as paired data. So let's see what are independent and dependent samples. Now independent samples are samples selected from one population that has no relation with the sample selected from the other. Or you can say that each subject has one observation. And then in the dependent sample, each measurement in one sample is matched or paired with a particular measurement in the second sample. Or we can say that each subject has two observations. So this is the basic definition of independent and dependent samples. Let's see one example of each to understand this better. First we'll see an example of independent samples. So let's say we have got two brands of petrol or gasoline, say brand A and brand B, and we want to compare the mileage given by these two brands. So what we did is we randomly chose 5 cars and assigned them brand A and chose another 5 cars and assigned them brand B. Now this type of sampling is called independent sampling because observations from group A and group B have no relation, or you can say each subject, that is each car, has only one observation. Then we took these two brands and this time we assigned both the brands to the same group of 5 cars. So first we asked them to use brand A and then use brand B. Now this is an example of dependent sample. Here you can see that each subject, that is each car, has got two observations, which is mileage from using brand A and then brand B. So this is the difference between independent and dependent samples or paired data. Now the independent sample test can further be divided into two cases, that is pooled variance and unpooled variance. And as far as the dependent sample test is concerned, there is only one case, that is paired sample t-test. So let's see each of these one by one now. First is the pooled variance. So we have two assumptions here. First assumption is that variance of population 1 is equal to variance of population 2. That is why it is called pooled variance. And second assumption is that population is normal. So here we use common standard deviation denoted by SP by using the pooled data from both the samples. Now the formula for calculating the common standard deviation SP is given here. We can also use thumb rule, that is standard deviation of sample 1 divided by standard deviation of sample 2 is between 0.5 to 2. After calculating the common standard deviation SP, we can use the t-statistic formula as shown here and calculate our t-statistic. And then we can use the degree of freedom as given here n1 plus n2 minus 2 for calculating the p-value. And then we can proceed with the rest of the steps as shown at the top. So that is how we carry out the difference of mean test in case of pooled variance. Then we have the next case as unpooled variance. So when the assumption of equal variances is not valid, we need to use separate or unpooled variances. However, the second assumption of normal population is still true. Now the formula for calculating the t-statistic is shown here. Here S1 and S2 are standard deviation of each of the samples. and N1 and N2 are the sample size. Then the formula for degree of freedom is shown here. So to calculate the degree of freedom, we are using a variable C, which can be calculated by the formula shown here at the bottom of the screen. Again, as I said earlier, you don't have to remember all these formulas. Just have a look at it and move on. So after calculating T statistic, we can proceed with the rest of the steps as shown here at the top of the screen. So that is how we carry out the difference of mean test when the sample size is less than 30. Now let's see the difference of mean test in case of dependent samples. So in case of dependent samples, we have paired t-test. We know that each subject is measured twice, resulting in pairs. Also, our assumption about the population being normal remains valid for this test as well. Now the formula for calculating t-statistic is given here. Here d bar denotes the sample mean of the different sets. We can calculate d bar using the formula as shown here on the screen, and then we can use d bar to calculate t value. So that is how we do the difference of mean hypothesis testing when sample size is less than 30.